Namaskar, welcome to Exercise Explained. In this video, we would be doing propagation of sound waves, exercise 8A, ICSE 9th. I would be solving all the numericals of the textbook. So, without any further delay, let us start with the video. Consider subscribing to the channel, and if you like the video, do share it with your friends. So, coming to the first question. The heart of a man beats 75 times a minute. What is its frequency? And B part is what is its time period? So, the definition of frequency says that it is the number of oscillations per second. So, here we can see that it is 75 times in a minute. So I would have to find out how many times it beats in a second. So that would give me the frequency. And after getting the frequency, I would be finding the time period. By the formula, time period is equal to 1 divided by frequency. So for finding frequency, I write it as number of vibrations divided by time. Now time I need to convert it to seconds. So we get it as 75 divided by 60 seconds. So 75 by 60 gives me 1.25 second inverse, which is nothing but 1.25 hertz. So second inverse can be written as hertz. Hertz is the SI unit of frequency. Now since we have got the frequency, we can find the time period. So time period will be 1 by frequency. So frequency I've got 1.25, so I can write it as 1 divided by 1.25. If I multiply numerator and denominator by 100, I get it as 100 divided by 1.25. Sorry about that. So if I cancel this by 25, 25 into 4 is 100 and 25 into 5 is 125. So I get it as 4 by 5. 4 by 5 is nothing but 0.8 seconds. So the time period happens to be 0.8 seconds and the frequency happens to be 1.25 hertz. Hope you guys have understood this question. Let us get into the next question, that is question number 2. The time period of a simple pendulum is 2 seconds. Now, the definition of time period says that the time taken to complete one oscillation. Now, oscillation means to and fro motion. So that is going and then coming back. So time period is 2 seconds. That means if let's say it starts from here, it goes to here and comes back in 2 seconds. We need to find its frequency. So we can use this formula, time period is equal to 1 by frequency. So we can write frequency is nothing but 1 by time period. So I've written frequency is equal to 1 by time period. So F is equal to 1 by capital T. Time period is denoted by capital T. Frequency is denoted by small letter f. So f happens to be 1 divided by 2. So 1 by 2 is nothing but 0.5. And since it is frequency, SI unit will be hertz. So this was a really simple question. Getting into the third question of exercise 8A, ICSE 9th. The separation between two consecutive crests in a transverse wave is 100 meters. Now, suppose we consider a wave like this, up and down. So here, the separation between two consecutive crests means the separation between two consecutive top parts. As you can see, we have made a diagram here. So this is the wave which is going. So the separation between two consecutive crests means from A till C. So this much distance is given as 100 meters. If the wave velocity is 20 meter per second, find the frequency of the wave. So here, this is the 100 meter here. So wavelength is 100 meter. Now this is denoted by the letter lambda. It is written like this, as you can see here. Velocity is given as 20 meter per second in the question, so I take it as v. So I use v is equal to f into lambda. So as I use v is equal to f into lambda, I can find the value of f, and that is what the question has asked. So here f will be equal to v by lambda, since lambda goes to the other side. So I can write it as v by lambda. Both are in SI units, so nothing to worry about. We can directly put the values. V happens to be 20 and lambda happens to be 100. 20 by 100 gives me 0.2 Hertz. So the frequency which I've got here is 0.2 Hertz. So that completes this question. Now coming to the fourth question, which happens to be the last question for this particular video. Fifth question onwards, I would be putting up in a separate video, the link for which will be there in the description below. A longitudinal wave travels at a speed of 0.3 meter per second. So velocity is given as 0.3 meter per second. And the frequency of the wave is 20 Hertz. Now f is given as 20 Hertz. Do notice that both are there in SI units, so we don't have to worry about anything. Find the separation between two consecutive compressions. Now separation between two consecutive compression means wavelength. Do remember that. Separation between consecutive crests, or separation between consecutive trough, or separation between consecutive compression, or separation between consecutive rarefaction all mean wavelength. So we need to find wavelength. So we would be using this formula only, that is V is equal to F lambda. So here I have just made a diagram which would denote the situation. So these two are the compressions in a longitudinal wave. The separation between these two is given as the wavelength, and that is what we are supposed to find. So I use V is equal to F into lambda. So lambda happens to be V by F because F goes to the other side. So lambda is V by F. So lambda happens to be 0.3 divided by 20. So 0.3 divided by 20, I multiply numerator and denominator by 10. When I multiply the numerator and denominator by 10, what I get over here is 0.3 into 10 gives me 3 and 20 into 10 gives me 200. So 3 divided by 200, which happens to be 0.015 meters. So 0.015 meter can be written as 1.5 into 10 to the power of minus 2 meters, which is nothing but 1.5 centimeter. Now if you are comfortable leaving it here, you can definitely leave it here in meters. You will definitely get full marks for it. And if you want to convert it to 10 to the power of n form, so you can convert it. There's no issue at all here. The textbook answer, I suppose, was given in centimeters, and that is the reason I've converted it to centimeters. Meter, you can definitely leave it here because this is the SI unit. I hope you guys have understood the questions which I have solved in the video. If you like the video, consider sharing it with your friends and subscribe to the channel. So see you guys in the next video, the link for which will be there in the description. That is from question number 5 onwards. Dhanyavad.